Thanks for joining us once again. I'm Sammy K. Powers, and this is the PHP Roundtable. This is a live podcast of developers discussing topics that PHP nerds care about. And the ultimate goal of this live podcast is to learn a little something from each other. If you're listening live and want to be a part of this little live airing, send a tweet to PHP Roundtable. I've got it open right here, looking for notifications, and we'll try to address your comment and or question live if we can. Sometimes it's hard to kind of keep up with all that stuff, but if you want to join us, it'd be fun. I'd be willing to bet that a lot of developers' first-time experience with asynchronous programming is dealing with AJAX requests in JavaScript, as was mine. And some of us we've experienced this little thing called callback hell when dealing with multiple AJAX requests that depend on one another. The topic of asynchronous programming is actually bigger than AJAX in JavaScript. In fact, PHP can do async too. Today we're going to discuss asynchronous programming in PHP and how we might be able to implement it in our own projects using various libraries. We're also going to take a look at how async features could be added to PHP core to support async natively. Now that we know what we're talking about, let's meet our panel, and as always, in no particular order, we'll just kick this thing off with the developer at Stripe. I don't know if it's just the developer at Silver Stripe, but a developer at Silver Stripe, Christopher Pitt. Welcome, Chris.
Thanks for having me, Sammy. It's one of many developers, yeah.
That's what I assumed. Also, a prolific contributor to PHP and HHVM, the hippity-hoppity virtual machinery, Miss Sara Golemon. Welcome, Sara.
The sole developer at my office. Population me.
Nice. Also, Aaron Piotrowski, author of the Async library Icicle. Welcome, Aaron.
Thank you.
And actually, Aaron, I was just commenting to you earlier. I remember you from Midwest PHP 2 years ago, and I was chatting with some friends, and you came over with a card. You handed us a card, and you're like, "Check this thing out." And you had just launched your Icicle library, and you were showing everybody a little snippet of code on the card itself, which was really cool.
Yeah, it was just a cheap little way I could try and promote it. You know, I got some business cards for like $30. I had to get 1,000 of them, so I still have a ton of them left. But
that's awesome. Well, it obviously worked because your library is pretty popular. We're going to get to that in just a second, but I just wanted to start by kind of phrasing this conversation in a typical blocking environment that most of us PHP devs are kind of used to, and kind of ease us into this async idea kind of gradually, and then get to more advanced concepts. But say we just have this script, and it's pretty basic. It's got one line that basically uses maybe file get contents or just some function to load a file of JSON, for example. And we load on that one line, it just loads this file into this variable, and on the next line we use JSON decode to turn it into an array or something like that. So, from a typical perspective, we think, okay, the runtime environment's going through each line, and it gets that part where it says read this file, and it stops and it sits there and waits for that whole process to happen, and it reads all the file and it gets it into that variable, and then it goes to the next step and is like, okay, now what do you want me to do with this variable? Oh, we could JSON decode it into an array. So that's a typical blocking environment. So how does async look at that differently in a non-blocking way?
Well, async, like you said, it's always I/O that your programs can be blocking on. So to look at it in a non-blocking way, the programs, like you said, normal PHP program is going to hit file get contents. It stops, it waits for that to complete before continuing to the next line. An async program is going to want to keep going, executing other code while it's waiting for that request to complete. So you need some way of telling the program, okay, when that's complete, here's the code that you're supposed to execute, and normally that's like a callback.
So I like to use cooking metaphors because I love to spend time in the kitchen. When you're preparing a meal, you might throw a pot of water on the stove to boil, but that boil is not going to happen instantaneously, right? It's going to take a few minutes to actually get the temperature up and get boiling. So you do other things at the same time. You chop some onions, or you maybe lay out a pan that you're going to stick in the oven that you're also preheating. That's something else going on at the same time. Each of these are little asynchronous tasks. And one task is heating up the water, one task is heating up the oven, and one task is chopping the onions. And then maybe you have the fourth task where you're like, well, I've got nothing better to do right now than wait for these things to happen. So that's just sort of like your waiting task. In the land of programming, that might be, okay, I've got a task that's waiting to get data off the disk, so that's a file read or something happening over there. I've got a task that's waiting to get a SQL result back from a database server. That's another task. And it's getting as many of those things happening at the same time, so that the time you spend actually waiting and actually doing nothing is kept to a minimum. If you were to cook your meal by first boiling the water, and then once the water's boiling, you chop the onions, and then after you've mixed everything together in a pot, you finally start the oven preheating, your meal's going to take 2-3 times as long to cook, even though you've done the same amount of total work. So it's all about getting that total time to deliciousness down.
Yeah, that's a fantastic analogy.
And if you don't time it well, Gordon Ramsay's going to be swearing at you.
Well, I guess from a typical developer who's never experienced AJAX, or like I said AJAX because that's kind of the way that I first discovered async. When you're in JavaScript and you're trying to make this request over HTTP, especially if you're using something like jQuery, there's this thing, and Aaron, you mentioned this, the callback, or you send it this function or this executable that gets executed after that operation has finished or completed. So I guess that would be the most kind of confusing thing from a blocking perspective. If you're used to just kind of going from line to line, it's like, well, I asked for this file, and on the next line it starts to parse something, but there's nothing there yet because it hasn't finished doing its thing. So so in async, we just think of everything as kind of like units of executable bits that we just kind of toss around. Is that how we think about it?
In particularly with Node, when you have to write callbacks for everything, yeah, if something's bit of code is dependent on something, that has to go in the callback, and then if you have something in that callback that's dependent on something else, you have another callback within that callback, which is how you kind of fall into the callback hell that you mentioned before. And so there's other ways to look to program asynchronously, which is what you're probably going to get to later. I don't want to jump ahead of your plan here too much, but that's typically how async is you have these little snippets that can be executed, and your scheduler or the event loop takes care of executing those snippets when an event happens, generally, network I/O, disk I/O, something like that.
Yeah, I mean, that's just sort of the whole idea of, well, okay, I won't say the whole idea, because one of the most common ways to implement asynchronous programming is to just say, well, here's a thing I want to do when it's possible to do it. You worry about when it gets done, because it's sort of self-contained, it has no side effects. Just get this thing done for me, and then that scheduler, that event loop you talked about, that's the thing that says, okay, I can only really do one thing at a time, and the thing I'm going to do right now is that callback. Things in a complex dependency tree, that's the hell. That's when you have to say, well, here's the callback to do when those callbacks have run, but not those callbacks. And
So is there any techniques of avoiding callback hell, to where we have I've seen snippets of code that's just callback that's embedded in callback, which is embedded in callback, and you just get this really deeply recursive looking crazy bit of code that no one really can understand at a glance?
Certainly. I mean, the callbacks are just one way of solving that I'm only going to do one thing at a time problem, but there are many ways to solve that problem. Other ways of solving that problem are some native async await sort of features like you have in ECMAScript 7 or Hacklang, or I think C# has these as well. Or you might have a truly threaded application where you're setting up these mutexes and everything's got side effects and it's a terrible way to do things. Java. And then there also the approach of like splitting everything into tiny little microservices, and you can just let curl or some wrapper for curl like Guzzle do all the work of just saying like, hey, here's all the jobs I want to get done. You guys just get the jobs done, and then I'm just going to wait for all of your answers at once. And you sort of build your own tree of dependencies around that, and that gives basically you then take the role of the scheduler. So you're not doing callbacks. You have your logic baked into your scheduling. These all represent sort of different stages in the evolution of how we as programmers have come to think of asynchronous programming, and they all have their pluses and minuses. And it really kind of depends on the complexity of your application and how much you are just an old fart like me who likes to do things the hard way.
Probably the first thing that a lot of people will think of, though, for that to answer that question, is promises. And what promises are is that they're kind of like a placeholder for the eventual value that will result from an async operation. So when you call like a function that rather than taking a callback, it returns a promise, and then you can use that promise to assign, at the most basic level, you can assign then callbacks that happen, once that value arrives. You can transform it.
One of the things I was going to say, one of the things I really like about promises is that they sort of give you a little bit more flexibility than the traditional callback approach, in that the event that's going to happen could have already happened, or it could be yet to happen, and they deal with that ambiguity for you, which is really nice.
Probably the best thing is it allows you, rather than writing nested callbacks, it allows you to chain them and represent problems rather than this nested callback hell as a set of interdependencies, more akin to what you're used to writing, where this function call depends on this function, and that sort of thing. And that's sort of the first step to escaping from callbacks.
Yeah, but it is, they're still, depending on the implementation of the language, they are still just syntactic sugar for callbacks. So instead of nesting callbacks sort of to the right of your screen, or I guess the right's that way for you, instead of nesting them to the right of your screen, the promises are doing that for you. And the nesting you have to do is in the code that makes promise APIs, if that makes sense. So promises are one half of the solution to nested callbacks, and if you have APIs that return promises, like the jQuery stuff in JavaScript, or the fetch stuff in JavaScript, those return promises, and you can work with them, and so it simplifies that. But if you're trying to write your own interface code to do stuff, you have to work with promises and you have to compose them. And so that's kind of where you do the nesting, but not in line where the code's used.
Yeah,
go ahead. I think you hit on one of the sort of dirty little secrets of asynchronous programming, which is that no matter what your artifice is for it, whether it's a promise or it's a callback sequence or it's an async await, like, they're all solving the same problem, and so way down to the bottom, they're all actually doing a lot of the same kind of work, just with different ways of looking at them. And yeah, callbacks are going to give you the sort of inverted program logic, where the last thing that you do is the first thing that's in your callback tree, which I hate personally, or something involving promises, which is a bit more linear, or async await. I think I see as sort of the more other end of that, where everything looks almost exactly linear in terms of how your program flow executes. You just have these sort of expectations that actual program execution might jump all over the place while it's going. But it's still linear from an individual task sort of standpoint.
my experience with promises has actually just been in the latest ECMAScript 6 versions, so the latest JavaScript that's kind of being adopted by browsers. And the cool thing is that I do like the Fluent API aspect. That it kind of looks it's more easy to read for me. So it's sort of just like once you get this data. This promise, you could use a .then syntax to say do this when it's successful, and then you could do a .catch for catching errors or whatever. And there's a couple different states of promises and stuff, and I'm still trying to wrap my head around all that stuff. But Shubham on Twitter actually asks, could you guys explain the difference between futures and promises?
Generally, they're kind of the same thing. They're sort of just synonyms as far as I know. So it really depends on what language or what library. Sometimes a future is the exact same thing as a promise. Sometimes there are subtle differences in like how they can be resolved.
Yeah, I've always thought of them as basically the same thing. Like you said, there can tend to be some subtle differences from language to language. Like a C++ future and a JavaScript promise are going to have some differences in how they're actually implemented, but one is going to be immediately recognizable to the other once you wipe away the language differences.
So they're both kinds of monads, which I think is an interesting way of seeing that the differences between them don't matter as much as how they're used and how they're composed. It's kind of easy. Well, I mean, I say it's kind of easy. It's probably the easiest way that I've found to try and understand monads is that they are boxes in which you put data, and you can call the same method on that box, and it'll keep on executing on that. And then at some point, you can pull data out of it. So a good example of this is the null object pattern, where you have maybe a scalar variable in PHP, and you wrap that in a class, and then you can call method calls on that. And if the results of those method calls are null, then you're not going to get a null pointer exception. And at some point later, you'll say get value or if is null or something like that. That's a kind of monad. And promises and futures are very much like this because they abstract the repeated network I/O requests. Or sorry, that's they abstract repeated future values in such a way that you can keep on saying then and then and then. Something like you were saying, you're used to you like the fluent syntax of being able to say then, and that's at the heart of what a monad is. It doesn't matter what the return value is. You can always still call then and then and then. And so, I mean, if you think about them like that, there's really not a lot of difference between futures and promises, or in systems that have that express a third kind called deferred. Like I know Icicle has subtle implementations of deferred and promises, and these things are, the only difference is in the access of methods or when you can resolve them. But it's small differences. It's essentially, promise is just a future value that you can call then on.
In Icicle, a future is the base class for promise and delayed. And the only difference between a promise and a delayed is that a promise can't be publicly resolved, and a delayed can be. So again, I think it just depends on the library, and you'd have to look at each specific library to see if there's a difference.
True that. Well, Sara, you mentioned threading earlier, and that's something that seems to come up when we're talking about asynchronous stuff. But I'm curious, and this is for anybody, what is the relationship between multi-threading and asynchronous programming?
I always like to give other people a chance to answer because I don't want to monopolize. But so I think they are not necessarily things that go hand in hand, but I think in practice it makes very little sense to not involve some degree of threading when you're talking about asynchronous programming, because typically asynchronous is going to involve something that you can block on, whether it's disk activity or network or whatever else. And the sort of programmatically easiest way to block on those things is to just do a select or a pull call, and the kernel will take care of letting you wait. The alternative is a busy loop where you're just constantly saying, hey, how about now, 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 and that's actually not good for your processors. Don't do that. So in practice, it becomes much more efficient and effective to involve threading to some degree. when you're talking about, you've got two tasks, both of which have to go to the network. You'll have one task that says, okay, I've sent out my write request, those packets have gone out, and I'm just sitting here waiting, so here's my file descriptor handle, and I am just going to sit and block on that in my own thread. And the second task does the same thing, and then the only application is watching those threads. That's kind of an implementation detail, though, for most modern languages, because you're not having to rewrite all of this code from scratch. Like these asynchronous patterns, like these are, I'm not going to say solved problems, but they're problems that have many solutions already. So in languages, like ECMAScript or something else, where you've got promises or whatever abstractions you have, you will typically have things appearing to happen in a single thread as far as you're concerned, only one thing necessarily happening in your request at a time that you know of. But under the hood, there's one tiny little lightweight thread that's watching that socket, or there's one tiny little lightweight thread that's watching the disk I/O, and bubbling that information back up in your main thread. So you don't have to worry about locking and mutexes and all kinds of things that can go horribly, horribly wrong if you get them incorrect. So it's kind of to come back to your question, like I think it's unlikely to see asynchronous happen without threads involved at some point in the stack, but hopefully you as a programmer don't have to deal with those things.
I think there's a lot of confusion with asynchronous and multi-threading, and people think that they're synonymous and the same thing, but they're not. Being asynchronous means that everything is happening in one thread, but nothing blocks on anything in particular. All I/O is handled in some, with callbacks or something like that, where nothing will block on like a file get content sort of call. Whereas, multi-threading means that you're actually executing something in parallel. You have two threads of execution that can be doing something on the CPU at the same time, or on two different CPUs at the same time. But being asynchronous doesn't necessarily mean that it has to be multi-thread. It's just using threads is a lot of times an implementation detail of accomplishing something in a way where you can have a thread that won't block on a particular task.
So I should probably restate one of those examples then, because you make an excellent point there. Asynchronous programming could be at the microservices end, where you've got endpoints that you're hitting with curl. Those are happening in different processes, which at the end of the day is kind of a different thread, but not in different ways. You're only doing one thing in your sort of main controller request. That's a single-threaded thing. There's no threading going on, and you're just looping multiple file descriptors in a select poll. So you're blocking in terms of you're waiting for all these 100 things to happen at once, but each of those 100 things is all happening in a different process, which is kind of a multi-threading-ish thing, but not. That felt really scattered coming out of my mouth.
Yeah, I'm not really.
I think it's also interesting to realize that this stuff isn't typical of traditional PHP architecture, and the biggest problem that we see when trying to excite people about doing asynchronous PHP, or even starting to learn the asynchronous constructs in Hacklang, is that the language traditionally is very top-down. The code you write is synchronous. The APIs you have access to are synchronous by and large. And we're trying to show people that they can write code in different paradigms. We're trying to show them that they can use promise-like code that they know from JavaScript, or coroutine-like code that they know from Go. And so these are new paradigms that we're trying to bring in, but people are still sticking with the same language, and the traditions of the language are getting in the way. So there are ways to get multi-threading in traditional PHP code. Like, you can install the pthreads extension from Joe Watkins, which is really great. But there are also concessions you have to make for that. So you have to run your PHP interpreter with Zen thread safety, which writes off a few other extensions you might want to use at the same time. But you don't have to use multi-threading in PHP to be able to do concurrent execution. You can use process control extension, which does process forking. You can run, you can use exec or pass-through or system to spawn a new script and read and write to that script to execute that stuff in parallel. So there are ways to do multi-threading-like things in PHP, which don't necessarily require a multi-threading extension. And you can use these paradigms in PHP in fairly traditional code.
I think you touched on one of the major problems that people run into when they want to try and do asynchronous PHP is that generally PHP is written to be run, on a once per request basis. You set everything up, run the request. It blocks for file things like file get contents or database queries, that sort of thing. But it doesn't matter because it's running within a web server like Apache that's multi-process, or Nginx that's multi-threaded. And so even though your single PHP script is blocking, you're not blocking the entire web server. Whereas when you're going to write PHP asynchronously, you can't have anything in your program that blocks because you'd be blocking the entire program. And that's a really big hurdle to get over because that means that you can't use a lot of libraries that are out there. You can't use a lot of the traditional calls because they're going to block. You can't use like the built-in MySQL API because all of those calls are blocking.
And it's not, that problem is not unique to PHP. It's just perhaps it's perhaps not helped by the traditional PHP APIs that are mostly synchronous. But other languages like Node also suffer from the same problem, and so they have libraries to spawn child processes and to have evented I/O on that to be able to track that stuff. And if you have a Node server that has a very busy loop that just does a lot of computational stuff, you're still blocking the I/O for the web requests coming in. It's not unique to PHP. It's just because of, as you say, the way that people have traditionally done. One script serves one request and then dies. A lot of that is abstracted by the web servers that do the multi-processing up to a point.
Yeah, if PHP started like Node, where everything was asynchronous to begin with, we wouldn't have this issue. So I was just going to say, it's just a matter of getting people to change the way that they're thinking about writing PHP.
That's definitely something that I want to look at here in a minute is the native support for that PHP has for asynchronous stuff. But before we jump into some libraries and the native language, I wanted to at least address, at least for a little bit, this one word that tends to come up when you're talking about async stuff, and that is concurrency. And I'm going to just throw out this little definition that I kind of threw together based on my understanding of it. And you can just tell me how far off the mark I am here. But concurrency, as I understand it, is basically it describes a program that has these little executable bits, right, like within the program, and you can execute them in an arbitrary order during the execution of the program, and then at the end of the day, after the program is done executing, you'll still have the same outcome as, say, like a typical blocking application. I know there's a lot more to it, but is that like the 30,000 feet up version of concurrency?
Well, I mean, I think it's part of concurrency, and it's called idempotency. Can I pronounce that? Idempotency. It's hard to say. It's the idea that for a given algorithm or a given task or whatever, providing X input is going to provide Y output, and it's not going to have side effects. So in a asynchronous application, it's really important to have your indivisible little bits behave like that. It shouldn't matter if the disk read that I'm doing happens before or after the database access that I'm doing, if they don't have any natural dependency between each other. And if their ordering doesn't matter, then the scheduler can do whatever the heck it wants with that.
Cool. I understand that there's the concurrency models and theories behind it can get into like a really deep discussion, and in fact, it's probably big enough to have an episode all by by itself. So I just wanted to at least kind of just throw that out there and kind of address some just the idea that, yeah, we're talking about async and this is something that kind of plays a role. So but moving on to actually the libraries, how do we actually implement async in PHP? Is the only way to do that right now is through libraries?
Yeah, pretty much. One that a lot of people are probably familiar with is React, and I know that gets used a lot. And it sort of takes the node model and uses callbacks for a lot of things, as well as then promises to try and model async operations.
You say that, but since PHP 4 we've had the exec function, and that is literally all you need to do starter async code, to do starter concurrently executed code.
Yeah, that's definitely true.
So how do you do that? You said easy.
You put the code you want to run in parallel into a PHP script, and from within your main thread you say exec and then the name of the PHP script. It's not a very scalable approach, but if you're looking for non-extension, non-library code that you can write since PHP 4, you can do that. Now, it's dangerous because you need to validate and sanitize the data that you put in there, and you need to use it sparingly, like you do with any of this stuff. But it may be a bit of a myth that you need like special architecture or special extensions or special libraries to use this stuff, because you don't. It's just a different way that you need to think about your code.
Doesn't exec block until that process is done?
Exec does, but proc open doesn't. So there are there are mechanisms.
I mean, you can redirect output and run it silently. It's not really.
You could no up and back run the process or whatever.
Yeah, exactly.
Yeah. You did mention one important thing is that that you definitely do not need any special extensions to do async in PHP. PHP just right out of the box, the core has everything that is needed to do async.
Albeit hacky and dangerous?
No.
Well, actually, yes.
Very stable.
Well, okay.
Well.
Hacky in the sense that if you're reinventing the wheel, it's probably because you don't realize there are other wheels out there, so there's probably going to be other mistakes that you make in your, I hate to use the word ignorance, but in your
naivety.
Naivety, yes, there's the word for it. Because again, as you guys were saying, I mean, at the root of it, async is all like it's a problem that's been solved in a lot of ways already, and there are a lot of ways to do that using the tools that we have. What makes async interesting is when there are good artifices in front of it to make it easy to use and make the program easier to read through and make it easier to maintain, and so that you don't make the stupid mistakes of creating locks that deadlocks or doing things that are going to screw up your code in unpredictable ways. Sorry.
Well, PHP though, right out of the box has like stream select and proc open that lets you use file handles without, or well, not file handles, but like network handles without blocking on them, and run another PHP process in parallel. And so with those two tools you can do a lot. You don't need extensions for that, and I guess that was the main point I was trying to make.
Cool. So in what context does async make sense for PHP? Like if should I write a whole web app that's based on, say, Icicle, for example, the Icicle library doing all async everything? Does that even make sense?
So I'm going to make a blanket statement, and that's to be: if you are blocking at any point in your application, you should try to you should try to async that to some degree. And I'm going to put a big asterisk next to that because not everybody cares about the timed interaction of their app. You don't necessarily need a form load page to load in 100 milliseconds instead of 250 milliseconds. So it's a trade-off of complexity and effort. But if you're If you're making a site where interactivity with user is a really, really high priority thing, then you don't waste any time. If you've got dead cycles, or if you've got two things that can block at the same time, like that's enough reason to make them async in my mind, because you're throwing away time to interaction on your user. Not necessarily request capacity, because your request capacity is not going to change much, but your time to interaction is very important, especially if you've got sales figures to support it.
WebSockets are also kind of a big use case for writing PHP asynchronously, because you can use some of the same code that you maybe already are using for your web app, and then to do WebSockets, you're going to have to write a whole process to handle those WebSocket connections. So doing that with PHP might be a great way for somebody that's already familiar with PHP from writing the last version of their web app, and they want to write something new. That might be the way to go.
And you don't have to jump. After you, sir. you don't have to jump. You don't have to jump headlong into doing a complete rewrite in async either. You can start slowly and just learn the fundamentals of concurrent execution as you go. Like if you're using a framework like Laravel, for instance, there are aspects to it that already lend themselves to concurrent execution, or to deferred processing, or to multi-process work. You can send units of work to a job queue. You can connect to a service called Pusher to send messages from a synchronous threaded background server that will get picked up in a WebSocket on a client. And there are all these different libraries and things that you can try just to get your feet wet and to learn about concurrent execution without having to do a whole rewrite.
Yeah, for example, like Icicle has the concurrent library that lets you push tasks to separate processes or threads, or depending on what you have available. And so it allows you to have your main thread be async, running, say, your WebSocket server, but then you can have a whole bunch of workers doing things that can block, because it's not blocking your main thread, and you can have your existing application code live there.
I was just going to add, when we were trying to talk over each other there, that asynchronous programming actually doesn't stop at the server. The client is a great asynchronous controller for your application. If you're doing something, kind of Web 2.0-ish sort of thing, where you're making XHR requests, those XHR requests are sort of a form of asynchronous execution. You might be having your main page load up with no real content, and then you're pulling in, news stories, weather pieces, shares, whatever, as different XHR requests. That's kind of an asynchronous thing, because you've got multiple things maybe happening on different servers via their various endpoints, and then all coming back onto the client. So you may be doing asynchronous stuff already and not realizing it.
That's the best way. When you're doing it right and you don't even realize you're doing it right.
But it's so easy.
Well, there's actually a pending PSR dealing with async stuff. Is that right, Chris?
Yes, there is. There's actually an organization on GitHub. If you go to github.com/async-interop, there are a group of folks who got interested in standardizing things like event loops and promises for PHP. And so we're working on creating an implementation and sort of formalizing thoughts around a PSR, and then we're going to take that to PHP Fig. I say we, I'm doing virtually none of the work, but there are clever people actually doing work there, and we hope will become a consideration for future PHP standards.
So the PHP async interop group, is it what it's called, right?
Yes.
That's not separate from the Fig, the PHP Fig right now, but they're developing, getting together and requesting standards be proposed to the Fig. Is that how it's working?
Yes. So I initially proposed doing PSRs for promises and event loops at Fig, and a lot of folks were interested, and a lot of Fig folks took up the challenge of or put their names forward as editors and coordinators and that kind of thing, the usual Fig process. But most of those folks thought it would be a good idea to have implementations before writing out the standard, just to make sure that the things that we were doing were practical for the community. And so that's why it's a separate repo or organization on GitHub. But the idea is to take those standards recommendations to Fig for votes and follow the usual process when they're done.
Sweet. It'll be interesting to see where that goes and how much async starts seeping into an average PHP developer's life cycle when they're developing code and stuff. And speaking of which, looking at async more from the kind of the native support that PHP has, I'm curious. PHP 5.5, we got generators, right? So you could use the yield keyword instead of the return keyword. So you can return like bits of data output, and every time you call it function, it'll return a little bit more and a little bit more. Does that help us with async stuff at all, or is that completely unrelated?
Well,
before Aaron, can I just, before you drop the knowledge, because I know you're going to absolutely hit this one out the park, I just want to say,
waiting.
There's only so much time for us to discuss generators and how they're used in async now, but coming up there's actually a Nomad event called Day Camp for Devs, a thing run by Cal, and a big focus of that's going to be talking about the asynchronous stuff, which I think Aaron's doing the talk, and Sarah's going to be there, and I'm going to be talking on generators as well. So if this stuff interests whoever's listening, then perhaps consider signing up for Day Camp for Devs, because it's going to be a day of really awesome async knowledge bomb. Okay, Aaron.
We'll get the band back together next week.
Yeah, I'm going to try and make this fast because we could have a whole PHP roundtable on this. But yeah, that's pretty much what Icicle is all about, is using generators and using yield. So rather than having to define callbacks on like promises, Icicle calls them awaitables as a whole, but think of them as promises because they essentially are. And so when you yield a promise in the generator, in the coroutine, then the scheduler pauses execution of that coroutine until that promise resolves, and then either evaluates the yield statement to be the resolution value of that promise, or if like the promise is rejected, then it throws the exception into the generator. And so it allows you to write asynchronous code that basically looks just like synchronous code, except you have yield sprinkled in. And if you're familiar with any other languages, like C# has async await, Hack has async await, it's the same sort of model. It's just that PHP doesn't have those keywords and that ability yet, but that's what Icicle sort of fills in for PHP at the moment.
I love that you used the word "yet" in there.
Well, keeping my fingers
crossed. Someone needs to write some async await stuff for internals. I'm not sure who. Probably someone who knows and does a lot of internals work.
I've started playing with it already because I'm already missing Hack. I find it really hard to actually develop on HTTPM right now because it takes forever to compile. But I've been playing with putting async and await into PHP, and I think once I have a good prototype, we're going to see an RFC. Doesn't mean it's coming soon, though. Sorry.
Yeah, that's probably like a PHP 8 sort of thing, I'm guessing.
I don't think it's quite as bad as PHP 8. I think, so I would say 7.2 is not out of the question, but it's not very likely. I think 7.3 or 7.4 have definite possibilities, though, depending on how long the 7 tree lasts for.
Yeah, keep me looped in on that. I'd be very interested to look at or contribute to that a bit.
As a matter of interest, because I know this isn't JavaScript hour, but Node actually supports using generators as coroutines in exactly the same way as PHP does. And ES7 is introducing async await, but it's not standardized yet, so it's not supported in Node yet. But that's pretty interesting to see them converging on the same paradigms for doing this stuff.
Python kind of went down the same path, actually. They had yield and then even yield from, and now has async await in, where are they on, 3.5, 3.6? So
Yeah,
PHP might follow a similar path.
and it says something about the naturalness of solving certain problems that Facebook put async and await into hackling. Well, before that, they were actually using generators to implement the equivalent of async and await. So I mean, there's a very natural progression of like, well, okay, we have a synchronous model, and now we want to get some asynchronous stuff, but we have these generators, which are a specialization of coroutines, so we can make that happen. Well, we want it to happen better, so we want a different specialization of coroutines. We're going to do that through async and await. And you see that in ECMAScript, you see that in C#, you see that in all these languages that do the same thing. So I don't think it's that unlikely to see something very similar come into PHP. I don't think there's... Yeah, I'm going to leave it at that.
So for those who aren't familiar with Hack or have never used async and await, can you give just a quick example of how that might be implemented in a future version of PHP?
Well, I think the best thing to do in the interest of time is just say, go out and Google, async await under either ECMA 7 or C# or even Hackling has a good write-up of how to actually use it. But the gist of it is, you write normal code. You just write code how you've been writing it for the past 20 years, which is like, this comes before this, which comes before this, which comes before this. And instead of doing a regular $a equals foo function call, you would say $a equals await foo function call. And that await is a signal that says, yeah, I expect the call to foo to take a while. This is some kind of a blocking function that it's fine. Pause my execution here, go and do something else while we're waiting for foo, and come back to me later. It also requires that foo, in turn, has been written to expect that sort of pause. So it might be implemented as async function foo, blah, 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 and it'll have various await statements that indicate its pausing points, and then a final return that says, okay, here's my actual value to throw it back. So
you basically... Any say, for example, file get contents, you could just say await file get contents. Nothing. You wouldn't even namespace a different file get contents. Like it's not like you're creating two different ones, right? You're just literally adding a keyword and then suddenly it becomes async.
No, because you do have to have sort of that knowledge of where the good breakpoints are. File get contents as it is has got a select call in there somewhere deep buried, or it's a blocking stream and it's got an fread buried somewhere in there that is going to be blocking. So you have to introduce some degree of knowledge of when to stop and when to come back to it. So file get contents is not automatically going to be asynchronousable, but you might have another function called file await contents or something like that that would have that knowledge built into it and have a little bit of extra machinery built around it to deal with the pauses. But yeah.
So a lot earlier when I spoke about promises, just moving the nesting elsewhere, someone has to implement it. Like Sarah says, someone's got to make that asynchronous file get contents. And so right at the forefront of this, right at the edge of doing async in PHP, there are people writing those now. Like Icicle, there's a non-blocking I/O thing going. AMPHP has it, React has it. And at the moment, you're going to be writing some code, and you're going to have to be aware of how to write that code asynchronous. Even if you've got an asynchronous file reader and writer, even if you've got an asynchronous WebSocket library, there's still going to be code you've got to figure out how to make it async. But as time progresses and these things become more standardized and more commonplace, those are going to be taken care of. Just like you wouldn't make a new Symfony HTTP request library because that's there and it's pretty common and popular and well tested. At some point, the majority of the code that you're going to write in your day-to-day job, there are going to be asynchronous implementations for it if there aren't already. But for the moment, you can't just put await or even yield in front of normal blocking code because it's still going to be blocking code.
So it sounds like there's, even with the keywords, you can't just sprinkle a few awaits in there and suddenly you got async code, right?
Well, you can't do that with promises either. If you use libraries that return promises, In JavaScript, I'm talking about now, but the same applies to PHP. If you use libraries that return promises and you compose promises, you don't have to know anything. You can just do your thens. But if you have to write some code to be asynchronous, you have to compose a promise yourself, and that's not as simple as using then. You have to create a new promise instance and tell it when to defer and make sure that the code that defers it isn't blocking. That's code you have to write unless you're using an API that already does it for you, like fetch or like jQuery's promise built-in stuff.
And this can sound kind of heavy if we're talking about it from the perspective of migrating existing synchronous code into an asynchronous world. You've got to change all these things around. But if you start thinking of it as an asynchronous problem and you start thinking about writing new code asynchronously, it actually becomes quite natural, because it does, again, it follows that traditional synchronous path, but just with these little, like, yeah, this is going to take a while, so just wait that, but it's cool pieces in there, because you've got all those standard libraries that deal with the common things, like waiting on a process or waiting on a socket. Hackling's asynchronous stuff, for example, has got a whole bunch of stuff that's just straight up delivered as ready to go async. There's a curl exec function that is an async version, and you can actually see the source code for it. It's all written in PHP code. It's about that big, and it just sort of says, do an awaitable, select, read, check state, loop. Do we got to do more? It looks a lot like existing curl code, but just with that one little asynchronous select in there. But you don't have to build that because other people will.
That's great. I'd love to run a step debugger through that just to see how all that stuff gets executed, because I'm still fairly new. I mean, I've worked with async for a long time, but I haven't actually really implemented it properly, especially when it comes to PHP stuff. So I'm excited to see what actually comes out of this with the PSRs and then the stuff that, Sarah, you're talking about adding to PHP 7.1, I think you said, right? The next version.
No pressure, right? Yeah. No way 7.1 is it hitting. No way is that happening.
But it's getting to about that time where we need to start wrapping it up. So I wanted to actually point people to the show note repo, because Chris Shaw's been tearing it up. He's been in there adding show notes for episodes, and it's been really awesome. So thank you, Chris. If you would like to contribute some show notes to some previous episodes that don't have show notes, it's all in Markdown. Just go to github.com/PHP Roundtable. You'll see a repo in there called show-notes. And you can not only send a PR and contribute to open source, but you'll be contributing to people who are kind of watching along and want to click on the links and stuff like that. And you can learn a lot out of it. Every time I have an episode like this one, for example, I'm definitely going to listen to this one later in my car, and just kind of like really let this stuff sink in, so that I can really get the knowledge of these experts on the panel, just let them absorb into my brain and learn this stuff even more. So when you're sitting along,
it's narcissism. You just want to listen to yourself.
Well, I like to skip over the parts where I'm like blabbering on and be like, okay, let's get to the real meat of this thing. So, but I want to wrap this thing up with a developer shout out, and this is a segment that recognizes somebody in the community for being awesome, being an awesome developer. And the sponsor of this segment is Laracasts, and Laracast.com is giving us a $50 Amazon gift card to gift to this other person. And if you've never heard of Laracast, it's just this really great website. It's a great resource to learn a lot of new things about PHP, how to program, how to use your IDE, how to test, how to do a lot of different things. And there's just screencasts. So you sit there and you just eat popcorn, and you basically learn to code as you're eating popcorn and watching it. So thanks, Laracast, for sponsoring the PHP Roundtable so consistently. And for this episode, I asked the panel to nominate somebody who maybe helped the async community a lot, and the panel nominated Stephen Coakley. So, Aaron, why did you guys nominate Stephen Coakley?
I nominated him because he has really helped contribute to the async interop group, talking about the event loop standard that we're working on, as well as he's also the main author of the amazing concurrency library for Icicle.
Excellent. Well, Stephen, I'm going to try to hit you up on Twitter or something and try to get your snail mail address and get this get a thank you card out to you, and send you a $50 Amazon gift card that you can use to buy asynchronous things on Amazon. I don't know if that's a thing.
You can wait for them to arrive asynchronously. How about that?
Yes, if you order multiple packages, they can be sent asynchronously.
You can do other things until they get there. Yeah.
You have to wait until they get there, and then you can program some more.
Get in the kitchen and start cooking.
Exactly. Oh, and if you're listening live, I actually didn't talk to the panel about this beforehand, so there's no pressure to stick around. But I after we go off the air, I'll send the link to this hangout to the Twitter land, and I'd love to just hang out with some of you guys and see what's up, and just drink a little wine and hang out and talk about nerdy things. And for finally wrapping this thing up officially. Let's go down the line and see if you guys have anything that you'd like to shamelessly plug. Maybe starting off with Aaron, do you have anything that you'd like to promote?
I guess I'm going to plug the Day Camp for Developers. Again, if you're really interested in this topic, there's going to be at least 2, I think, presentations that they're going to heavily concentrate on async. Mine, of course, will focus on Icicle, and Chris, I think yours it's generators in general. And
it's
I don't
generators in general. I'm going to do a little bit of the theory of making coroutines about them, but I won't go into the kind of detail that Aaron will in terms of what Icicle's actually doing under the hood. I'm just going to show how to think about generators differently and how to use them generally and how they can make your code look better.
Yeah, awesome. So yeah, if you find this interesting, I encourage you to check that out and consider purchasing a ticket.
Excellent. What about you, Chris? You got something to promote?
I do. I, for the longest time, have been researching async stuff while people like Aaron and Sarah have been writing code to actually make it possible to do that. And I thought it would be useful to put my research into a book. So that's what I'm doing. You can go to assertchris.io/async PHP and put your email address, valuable as it is, into a text box so that I can spam you when the book's done. I won't really spam you, but if you want to know more about that, I'm going to give some updates in a while about how that's going and how you can contribute.
Excellent. And what about you, Sarah? Do you have anything to promote?
Well, as Chris mentioned, there's Day Camp for Developers coming up in about a week here. That's going to be lots of fun. I'll be the last talk on the line, so if you've gotten tired of it by then, you can just hang up and not watch mine. Then, let's see, I'll be out in Amsterdam for DPC this June, as well as Portsmouth for South Coast PHP. And since I'm fun employed / kind of retired but not, I'm going to be in a rally. Rally North America is running a thing called Big Sky Rally. We're going to be driving from Billings, Montana to Portland, Oregon, and we're raising money for a charity called Camp Sunshine. So if you want to donate to that, I should probably have a link, but I don't. But look for Team Crazy Cat Ladies in Rally North America Big Sky Rally, and donate to that cause. Or you know what I'm going to do? I'm going to tweet it right about after this show. I'm going to tweet a link to that. And I am Sarah MG on Twitter, SARAMG.
Awesome. I'll try to grab these links from you guys individually so I can post them on the website too. It'll be underneath your pick on the website. So you can go to not GitHub. You can go to phproundtable.com and look for this episode, and these links will be in there underneath on the right-hand side where it shows the panelists. So thank you guys so much for joining us. The next couple episodes we're going to have are kind of scattered a bit, but we're going to do another live recording at the PHP Tech event that's happening in St. Louis next month, which is going to be a lot of fun. So if you're going to be at PHP Tech, join us. There might even be another elephant raffle. There might even be a white Kung Fu elephant raffle. I don't know, maybe. So that might be something fun you can take home. So if you have something that you'd like to share about any particular topic that nerds care about PHP nerds care about, I'd love to hear from you. Just check out phproundtable.com. There's a form on there that you can fill out, and whether you're saying, hey, I'd like to be on the roundtable, or hey, I'd like to hear about this topic, let me know. I'd like to thank Aaron, Chris, and Sarah for joining us for this topic, this asynchronous topic, and we'll see you guys in the next episode.